Hello everyone, my name is Ganfei Wang. We have three members, Ganfei Wang, Shuai Liu, and Guantian Wu. We mainly study the weather station. Now let me introduce the weather station. We through DHT11 and the communication model BMT280 embedded in the embedded system. We successfully mirrored the data. Now let me introduce the first part, introduction. The main purpose of this report is to introduce and discuss the design and implementations of the embedded weather station project and the important results of our research. Through the two models, DHT11 and BMP280 in the embedded system, we create a more reliable weather monitoring system for users to meet the real-time and correct needs of the data in the different fields. Now let me introduce the background. Traditional weather stations and the embedded system weather station. The first one is the traditional weather stations. This station is an infrastructure embedded in the early days of the development of meteorology, which is usually located in different geographical environments. And the second one is the embedded system weather station. This station is a new generation of weather monitoring system based on advanced embedded technology, which is realized by DHT11 and BMP 280. In terms of project design and implementation cost, this project is constrained by limited cost and resource, and we are trying to reduce cost as much as possible to maximize the benefits. And we describe the implementation process of this weather station. Not only the hardware components, but also the software programming to serve the technical challenges. We use many methodologies, such as the embedded system implementation, Susan data occurs and transmission, data processing, and analysis. Through this data processing and analysis, we design two block diagram. The first is that there is no ESP 266 Wi-Fi condition. These DHT11 and BMP280 are entered into the UNO model and then displayed on the LCD. The diagram has the Wi-Fi condition. The DHT11 and the BMP280 entered the UNO model, transmitted to the ESP 8266 and then display on the LCD. These methodologies played a very important role in researching this project. Now let me introduce Shuai Liu.
The second part is procedure and findings. Now I will introduce our devices compositions and Arduino UNO IDE programming and weather station physical demonstration. First, let's know the equipment needed for the small weather station. We use the DHT11 and the BMP280 sensor to be used in LCD display. Arduino UNO and ESP8266 Wi-Fi module. In the experimental project of the design of the weather station, we tried two scenarios. The first is to display the weather data on the LCD display only, not the internet. The second option is to try to use the Wi-Fi module to display the data on the computer screen. The experiment is more challenging because you need to use network modules to connect devices to computers and set up the network addresses. The code. We use the IDE to write efficient code that allows us to design weather decision to read sensor data. Before writing the code, we need to download special libraries to connect the data from the DHT11 and the BMP280 to the LCD display, or through 8266 Wi-Fi module to transfer data to the computer program interface. Then we will introduce the physical demonstration of the weather station we designed. The first is only with LCD. We look at the sensors with our hands and find that the temperature and humidity will change. We can see the data. Next, the second is the weather station with ESP 8266, which we can observe on the computer screen. Is that we can see the data. The data may be changing with our room's temperature. This is a demo of our weather station on the computer screen. We can see the real-time weather on the screen. You can see the data is changing, right? It's still changing. Okay, that's all.
In as interpretation, we recognize the need for real-time collimated data. We developed a compact and efficient system utilizing Arduino Uno as a master. Our device as a present at the weather station measure the temperature, humidity, and air pressure simultaneously. The integration of relatively available components such as the DHT11 and BMP280 has allowed us to create a small yet impactful tools for predicting future weather conditions. The Arduino Uno serves as the controller, orchestrating data processing, while the ESP8266 module facilitates the transmission of information to a dedicated website. The simplicity of our working philosophy conducting controversies to detection elements as useless ESP, 8266 for website transmission believes the substitution of our system. In case in a robust cell, the device is designed for outdoor use, ensure protection against harsh environmental conditions. As we look towards the future, we invention enhancement to make our project more comprehensive. We aim to diversify sensors, explore widespread and classification for a deeper understanding of weather conditions. Additionally, we plan to implement low-power designs incorporation clean energy sources like solar, wind, and water to promote sustainability. Our commitment to open source communication and collaboration is reflected in our desire to inspire others. We believe that knowledge should be accessible to all, and our innovation serves as a tool for education and learning. In addition, our small innovation holds immense potential for progress. Together, let us strive to create a better world through innovation and share knowledge. Thank you all.